Okay, with the last two sections of this chapter, we're going to finish up with some information about solving triangles that are not right triangles. So we did this in Algebra 2 and a little bit in geometry also. But to deal with triangles that are non-right triangles that we want to solve, which means find all the angles and find all the sides, okay, we use the law of sines or the law of cosines. So the next couple days we're going to focus on the law of sines here. We're going to look at the simplest cases today, and then tomorrow we're going to look at what we call the ambiguous case. So the law of sines essentially is stated as such. It just gives us a set of equations that we can use to find missing sides or angles. Okay, so it just says that if we know the angle A and we know the side across from it, then we can fill in the two blanks of this ratio. And if we know the angle B and the side across from it, okay, we can use that as an equation. So I notice I covered up this part because ultimately an equation should only have one equal sign in it. And bottom line is if we know 3 out of these 4 parts, then we should be able to solve for the missing part. True? Okay, so they have it labeled as such because we can use any of the sides and any of the angles that we choose. Okay, if we knew something about the A's and C's, then we could use those two equaling each other. Okay, if we knew something about the B's and C's, then we could use those two. So ultimately, we're only going to use 2 of these ratios, okay, whichever ones are the most convenient. So let's take a look at an example. They give us a situation where we have a triangle. Angle A is 38, angle B is 46, and angle A, or side A that is 9. So a couple of key elements when we draw the picture are if we take this angle A, which is 38, this angle B, which is 46. So here's my A, here's my B, and then my side A is 9. Okay, it matters where that A goes. Remember, the little a has to go across from big A. Okay, little b is across from big B, and then of course if that's C, then little c is across from its angle with the same letter. Okay, so bottom line here is we need to solve this triangle, okay, which means find all the angles and find all the sides. Okay, so before we start though, I want you to notice what kind of case we have here. Okay, when we have 2 angles and the side that's not between them, remember in geometry we call that angle, angle, side. Okay. So the case that we're given here is angle, angle, side. And anytime that we have angle, angle, side, we're going to use the law of sines. Okay. So anytime it's an angle, angle, side situation, we'll use the law of sines. Okay, before we do that though, there's one other thing that we can do to find something easier than using the law of sines. And that's this angle here, because what did we learn in geometry about the 3 angles of a triangle? They add up to be how many? 180. So if I add these two together, that's going to give me 84. So that means this better be 96. So I know all of the angles. If I know 2 angles, I know the third, because I can add them up to be 180. All right, and then what I want to do is I want to set up a ratio to figure out side B and side C. So the ratio I'm going to set up is going to start with A because I have angle A and I have side A. So I'm going to write sine of 38 over 9 equals, and then I'm going to choose, it doesn't really matter which one we find first. I'm going to do B first, but I'm just choosing that because I felt like it. And so with that said, I would have sine of 46 over B. So when I write sine of 38 over 9 equals sine of 46 over B, the only variable I have is B. And so at this point, I would use the cross product. So I'd multiply top left, bottom right, bottom left, top right. I'd get B sine of 38, 9 sine of 46. And with that said, I could divide by sine of 38. And I would have my B value. Okay. So my B value, in this particular case, I would get, I'm going to make sure I'm in degree mode here because they gave it to me in degrees. So if I go 9 sine 46, divide that by sine of 38, I get 10.516. Okay, would be my length of side B. And remember, make sure it makes common sense. Across from the 38, there's a 9. Across from the 46, should it be greater than or less than 9? Should be greater than 9. It's across from a bigger angle, right? So 10.516 makes sense. And then, of course, if we want to set up to find C, Start out the exact same way. This time, though, we'll use sine of 38 over 9 equals sine of 96 over c. And then solving-wise, we'll do the exact same thing. Okay. Now, once we have these two sides, some people have asked, how come we can't just use the Pythagorean theorem? It's not a right triangle. Pythagorean theorem is only good for right triangles, so I can't use that. So you'd have to use the law of sines twice here to figure out those two missing sides. Okay. All right. Another example I want to look at is if we have the other case that the law of sines is used for is angle side angle. So if I had something like this triangle, where I had this be, let's say, 40, and this is, let's say, 55, okay? And I knew that this side right here was, let's say, 10. So if I'm given a side angle side case, let's call that A, we'll call that B, we'll call that C. Okay. And with that, I need to find either A or B. Keep in mind, why doesn't this work? Why can't I set up sine of 40 over A equals sine of 55 over B? There's two variables in that sense. That doesn't work. Okay. But we might say, well, then what are we going to do then? Because we don't know C. Well, again, we don't know because it's not written there, but can we find it? If we have 40 and 55, that makes 95. Okay. And if I go 95 subtracted from 180, that's going to be 85. Okay. So we don't want to do that. But if we want to find A, we can set it equal to sine of 85 over 10. And then the solving part of that, is that any different than what we just had a minute ago? Same thing, isn't it? All right. Questions so far? Okay. All right, so for our work today, when you're working on your section 5.5 problems, make sure that you're only doing cases that are angle side angle or angle angle side. If you find a case that says side side angle, so if you have two sides and the angle that's not between them, okay, save that one for tomorrow's work. Okay, this is the ambiguous case. There's a little bit more work involved when we have that situation, which we'll discuss tomorrow. Okay, so if you see one like that in today's homework, just skip it for now. Okay, you only want to work on the ones that are either angle side angle or angle angle side. Fair enough?